So thanks, Benjamin. Thanks everybody for coming. As Benjamin said, my name is David Woodard. I'm a software engineer with Eurotech, work in our IoT solutions group, which is involved in doing customer engagements and architecting of IoT solutions. Today, what I wanted to show is sort of a generic IoT architecture that can be built on open source technologies, and how that architecture is applied to some real world solutions that are in production today. So to begin with, what are the challenges of IoT? I think we've been showing the same slide for many years now, and it's still true. It's lack of open standards, still a huge problem. Vendor lock-in. I mean, there's some great IoT platforms out there, but you really have to be careful about getting locked in. Your IoT solution is going to have to evolve over time, and you need to make sure that as you evolve, the platform can evolve with you. And also with this vendor lock-in, the cost can sometimes really surprise you. Like you do a POC and it looks great, and then you start, how do I deploy this at scale? And all of a sudden it becomes really, unaffordable. And then fragmentation, this comes up. I think someone earlier mentioned, what's the point in collecting all this data if you don't do anything with it, right? So being able to have these systems communicate with each other and make that data useful in some way is incredibly important. So the principles of IoT or an open IoT architecture have to be these sort of four pillars. It has to be open and be able to communicate with each other within the different modules. It has to be modular, but it does have to be integrated as well. So having building blocks is great, but if those building blocks can't communicate with each other, then they're sort of monolithic things that aren't particularly useful. Management, both on the IT side and the OT side, so the data center side as well as wherever the data is coming from the sensors and whatnot, you have to be able to manage both of those things. They're not separate entities that you can forget about. Like you have to be able to manage your devices in the field, and you also have to be able to manage your infrastructure. And security. I think we've seen a few high-profile IoT security breaches already, but I think as a community we have to make sure that this is always one of our top priorities. So what are some of the features of an IoT, open IoT architecture? Device management and connectivity. So these devices in the field, how do you get to them? How do you update them? How does it, sort of manage its own connectivity? Edge processing. So I think there's still conversations and debate about how far the fog should, extend down into your solution. And the answer is always it depends. It depends on what problem you're trying to solve. But your edge products do need to be capable of handling some level of analytics and edge processing. Machine learning, this is, as we move towards autonomous, anything, machine learning is going to be at the forefront of that, so you have to have that capability. And business and application integration, so you have to be able to do something with the data. Like your business side has to be able to look at that data, act on that data, and make some use of it. And then again, the sort of bottom foundation of all of this is end-to-end security. So it's penetration level security, but also like the cyber security. So being able to act on security breaches if they happen. So if we start putting this stuff together, we can draw this sort of generic architecture where you have your connected things. These are your devices. These are your actuators. These are the things producing data. And next to that, very close to that, is going to be your edge device. People call these things by different names. I'm from Eurotech, so I'm going to call it a gateway. But you need something there to communicate with those sensors, do that data aggregation on the edge, and provide the remote management and data processing. You need something in the middle, like an integration hub, something that's collecting the data, something that's sort of the front end for managing your downstream devices, and passing along that data to further upstream platforms, such as analytics, such as enterprise applications. So if you start looking at these sort of blocks individually, I think we all know what the things are. They're different for everybody, right? So if you're in an industrial setting, these could be lathes or very large machinery that is doing some sort of physical role thing. They could be temperature sensors, they could be pressure sensors, they could be lots of things, right? Right. So next is the gateway. So what is a gateway? What does the gateway need to do? Well, it has to be able to provide remote management. So not just of itself, but also the things that it's connected to. Real time analysis on what's happening. So if it's detecting problems on the things that it's connected to, can it react to it? Can it be smart enough to perform some sort of business logic? It needs to be extensible so that if you need one use case may be slightly different than the next. How modular, how easily can you roll out your solution to what you need to do specifically? The integration hub. Again, management of devices, provisioning. Provisioning is a huge thing that people oftentimes don't think about when they're starting a project. Again, it's easy to do something once, but how do you deploy it 1,000 times? Like, how do you deploy it in a way that's both economical in time and in cost? Analytics, again, this is anytime we're talking about autonomous, whatever, we're going to need this sort of engine, this sort of large data storage, machine learning capabilities, has to be connected into all this. And then lastly, again, the actual business applications. So can these applications see this data that's being collected? Can it react on this data that's being collected? Can it make these numbers that are coming in useful in some way to the business? So kind of a different view of it. So we look at it broken down. We can actually start seeing the flow of information, like from the sensors going all the way up through the back end application. So the protocol translation. So going from Modbus or I2C or whatever it may be through the gateway, normalized telemetry data that goes into the integration hub, which can aggregate all that data and then pass it on through different routing mechanisms to the different either business applications or analytics engines. So it's easy to say, but how do you do it? I mean, it's a lot of work to do it correctly. So I think that why use open source? Well, I think this is part of the reason. We started, Eurotech and myself was lucky enough to be part of the Eclipse Foundation's IoT working group since it started, more or less. And to see how it has grown has been absolutely amazing, really incredible. So I think someone asked a question earlier, like if I'm a startup, how can I use the same open source technology? And absolutely, right? Absolutely. I mean, so if you look at the companies on the right, these are not small companies, right? And if you get involved with the working group, you get involved with these projects. Like, this is the community that you're dealing with. Like, engineers at these companies, a big part of their time is working with these projects and working with the community. And I think just some of the numbers there are staggering and probably outdated. I think they're probably on the low side. But if you look at the 300 developers and 30 plus projects, it's very impressive. So if we start mapping some of those open source projects to the architecture we've been discussing, you can start seeing where some of the pieces fit in. So on the gateway side, you have things like Eclipse Cora, which is a framework for managing edge devices, Drools, which is like an event type engine, Fedora for operating systems. Integration hub, we have things like Eclipse Kapua, Apache Camel and ActiveMQ for routing, message routing. For analytics, we have things like Cloudera's community data hub. So I mean, all these pieces are available. Also, OpenShift Origin, which is like a Kubernetes management system. All these pieces are open source and free to use. So Eclipse Cora, so this is something that's very dear to me. I'm the project lead, or one of the project leads for this project. It was donated by Eurotech 4 years ago, I believe. So it's pretty mature. It's been around for a while. Hopefully, at least some of you have heard of it. So a bit about Eclipse Cora. I'm not going to go into details, just we don't have time. But its purpose is to be a framework for running on an edge gateway. It's a Java OSGI framework that's really meant to enable application development. That's its purpose. But out of the box, it gives you a lot of functionality. Like when you fire it up, all the things I'm going to show here come with it. So it does things like allows you to manage your routing. So basic Ethernet, Wi-Fi, cellular type connections. You can come in here and you can configure all those things through the web UI. Setting up firewall rules, setting up port forwarding rules. Small things that are very, very powerful. It prevents your engineers from having to go be Linux networking experts. A couple of years ago, or I guess a year ago, we introduced something called KoRa wires, which is just a data flow sort of programming model. One of the things we ran into consistently is we would go to the OT guys in industrial environments and say, okay, this is the framework. They were very excited. We started getting into how you use it, and then we would eventually come to, well, you have to write some Java bundles. And that would a lot of times stop the conversation. Like, these are a bunch of industrial guys. They don't want to program in Java. They especially don't want to learn OSGI. So, I mean, that was always sort of a, wait a minute, we don't want to do this moment. So we introduced this where we abstract away some of the Java, right? We go in and say, okay, don't worry about Java. If you have Modbus device, for example, just take a Modbus asset, drop it on your graph, fill out your memory space, and then you're done. Wire the things together. So this has been a very, very popular feature of KoRa. Connectivity. So, Eclipse Cora is based on MQTT. And MQTT is great, but we extended some of the features. We put all the configuration in the UI. So you do all that, broker URL and passwords and everything go in here, but also managing the connection. So at least when we started doing this, MQTT didn't really have the notion of like maintaining connectivity, right? So if the connection dropped, the connection was just gone, and it was up to you to reconnect. So we put that kind of thing in here where we said, if your connection drops, we'll try to reconnect, but how often do you try to reconnect? What rate do you try to reconnect? Also, same with QoS. So MQTT has QoS, but they didn't really have priority of messages. So with priority, what you can do is say, if I go offline and I have these 20,000 messages in queue, which ones are the most important to send out first when I get my connection back? Right. So those are the kind of things we added on top of the existing MQTT protocol. It's kind of a different look of the same thing. So if you from the bottom up, we have the field device connectivity. So this is the Modbus and the OPC UA. These are all the things that are built into KoRa, right? So you don't have to go write drivers to do Bluetooth Low Energy. You just go in, you either use the OSGI services directly or use the KoRa wires in the next level up. So that level is where you can use KoRa wires to drag and drop and make a little data flow model for your application. Or of course you can do Java. If you have a very specific thing you need to do, what happens to us frequently is we go to these industrial guys and they say, well, we kind of use Modbus, but it's our own version of Modbus, right? And then they pull the engineer out of the closet who's been working there 30 years and he has his custom stack of software and says, okay, this is how it works. Well, then you can write your own sort of driver level to do the communication. And then at the top is the cloud service connectivity. And again, we're not, of course, being from Eurotech, I want you to use everywhere cloud. But if you're using AWS, you're using Azure, that's fine for us. Or what a lot of people do is actually will use multiple cloud services. They'll use everywhere cloud for data or device management, but then use AWS for just storing data. Right? This is a very common architecture. This is our sort of eye bleed chart. I think every presentation has to have one. This is ours. So these are all the components of KoRa. You'll see that all the different layers in there. I think these slides will be available, so I won't go through all of this. But there's a lot of features built into the framework. So yes, you can extend it. You can sort of do what you need it to do, but there's a lot of functionality built in natively. So Eclipse Kapua, so it's sort of the same story. Eclipse Kapua is the integration hub piece. So this is the piece that's going to sit higher up, maybe in the cloud, maybe on premise within your data center. But this is the piece that's going to do provide the connectivity for the field devices, for the gateways. It's also going to do device management and device registry. So being able to authenticate that the gateways or devices out there trying to connect to it are who they say that they are. And once they are connected, how do you manage them? Like, how do you securely send updates? How do you securely allow data to pass through the system? And also, this is where you would also provide provisioning. Like, very important. So again, getting into some of the specifics about Kapua, what can it do? Well, it provides you this sort of look of your gateways in the field, right? So you can click on a gateway, you see it's connected, and you can go look at the settings. Maybe you need to go change a setting. Maybe you just need to go see why something's not behaving the way you think that it should be. You can go in here and get like a nice snapshot of what the device is and what it's doing. So the Kapua version of the digital twin is what we call an asset, right? So not just seeing the gateway, but what's beyond the gateway. Like how can you actually see what the actual device that you're reading data from is? Like what are its settings, what are its data? And you can go do that through Kapua, right? So you can come in here and actually perform actions on your very end thing sitting out in the field. APIs, so this is allowing the integration into other platforms, so, to your business applications, to your analytics. There's a full suite of APIs with Kapua that provide that ability. So a few things we discuss, device provisioning, incredibly important, lifecycle management, configuration management. I showed you how you could go through an individual gateway and change settings for a specific service. But what do you do if you have to do that for 1,000 devices, right? All that stuff has to be automated. You don't want to go, click a bunch of buttons 1,000 times. Like it has to be automated. It has to be, schedulable so that you can say, I want to do this Thursday at 2 o'clock, not just at random times. So this slide I think is showing, so you can do all this with open source, but what happens if I need help. I don't have enough infrastructure to manage my own Kapua instance. Or I don't have enough resources internally to manage my own analytics platform. What do I do? Well, for all these projects that I know of, they're all supported by companies who are more than happy to talk to you about commercial products. And as far as I know, they're all directly related, right? So for KoRa, it's ESF. For Kapua, it's Everywhere Cloud, and so on. So if you do a proof of concept in KoRa and you want to move to production, you want some support, you don't change anything. You come talk to us, you take your same application, and you run it exactly the same on a commercial product, right? And I think that's incredibly important. Okay, so use cases. So almost anytime I work at a booth, people come up to me and talk to me about verticals and what are your verticals, and quite honestly, I don't even know anymore. Like IoT is really starting to go at such a rate that when our sales engineers come to us and talk to us about opportunities, they're all over the map, absolutely all over the map. It used to be industrial and transportation, but now it's vending machines and ice makers, and it's really, really all over the place. So what I wanted to show was a couple of success stories we've had getting customers to productions with their solutions. For a few of these, so part of why this is difficult is a lot of companies don't want me standing up here discussing their solutions. So oftentimes I can't say who our customers are. So some of these I'll talk about in generic terms, and some I'll actually be able to put up corporate names. So this is one where it's a connected clinic is actually dialysis machines. I can't put the company name up, but their use case was that they wanted these dialysis machines to be accessible both to the people who use it being the nurses, and also to the maintenance folks, people who have to go out and repair these machines. So two very separate flows of data. So we did this using ESF and our gateways and Everywhere Cloud to provide this sort of multi-path functionality. So we were able to go in, pull data off the machines in a secure way because medical was very tricky, and for us it was important that we didn't touch any patient information. Like we're just getting data off the machine itself, and then we can send that data to either the nurses who need to know is the machine being used correctly? Does it have the right settings? Does it have the right capacities for the different water tanks? But also to the operations guys who need to know how soon do we need to go out to service this machine. This one is Ariston. So they are a large company in Europe that makes boilers or hot water heaters for us Americans. And what they wanted was a little bit different because they actually wanted to provide an application for their consumer. So they wanted to build a solution that would help them with their analytics as well, so they can tell what is the state of these boilers deployed through people's homes, but also allow the consumer to have some interaction with their products. So again, two different sort of data flows. One, what can the customer see? What can their consumer see? And the other is, can their service guys get benefit from this as well? And the answer was absolutely. This has been probably one of our largest and best solutions. I think they have, I don't remember, thousands of these things deployed at this point. And it's running really, really well. They're really very happy, and it's been a great success story for us. Hitachi, so this is the Hitachi Power Solutions group. They had a unique case where they had these very large factory machines. I can't even remember exactly what they do. But their technicians were frustrated because they knew the analytics to use on a data set to predict failures. They absolutely, I mean, that was something they already had solved. But they couldn't connect all the pieces together. Like they had the engineers with the knowledge and the machinery out in the field, but they couldn't get those two things connected. So the thing that we provided is we said, hey, we can put a gateway, close to the machines that has enough compute power to run your very simple. So these aren't machine learning level analytics. These are more just mathematical analytics. But they could run that down very close to the machines. And they actually created two separate sort of data paths for this. One they wanted on site, so on premise. So they were actually able to deploy Kapua down on the factory floor. So this was doing the analytics processing, and then also one hosted in the cloud, so they could get in for more generic repair, maintenance, scheduling types of activities. The next was this Tram Manufacturer from Italy. So they're actually using one of our specific products for counting people. It's called a passenger counter. But this allowed them to, by connecting this to the cloud, they were able to start predicting usage patterns from their riders. So they mounted these passenger counters and gateways in all their trams. And they started seeing patterns like when were people riding, when people were not riding, when did they need to put more trams on the line to service their customers. I think the last one, so this is a building management. So this company wanted to, connect all the sensors that are in a building. So this gets into the, disparate, field protocols, all connecting to one gateway that's normalizing the data and presenting it in some useful way. And this company is, I think unique for us in that they are actually monetizing on the services provided by this platform. So they're able to go in and say, per use case, somebody can log into their system and on demand, purchase, certain usage patterns. Right, and this was their main goal, and it was highly, highly successful. But again, it's the same products. It's the gateway, it's the integration hub, and then farming it out to either analytics or business applications. And I believe, oh no, one more. So connected trains. So this one is another one where I can't put the company up, but this is getting into more high-speed trains, where we're getting into pretty rugged environments. If anybody's ever worked in this field, these trains are subject to massive amounts of vibration and heat at times. So they needed us to come in with a very specific type of gateway to handle those harsh environments. But what I wanted to point out here was that the software, the open source pieces that run on that gateway and that run as the IoT hub, they don't have to change. So the underlying complexities of implementing a very specific thing don't change the open source layers. Right, those are always the same. I believe that one. Yep, that one's it. So Benjamin, I think I'm on time. So maybe get a prize for that. So happy for any questions.
Questions for Dave?
In the Ariston scenario,
yes.
You mentioned that they were, obviously using open standards, but I wondered whether they were making that information available to the consumers as well, so that they could make their own use of it, rather than just through the provided dashboards.
It's a good question. I actually don't know. I don't think so. I think they see it very much as a commodity that they're selling, but I don't know. But they certainly could.
But at least they're using open standards.
So they're using open, yes, that's the thing, is they're using open standards. So absolutely, if they wanted to do that, they absolutely could.
Cool.
Other questions? We have one at the back. Let me go over there.
Hi, my name is Michael. I have questions about the Eclipse IoT stack. A lot of the apps in Industrial IoT tend to need real-time and even more than that, near-deterministic performance. I know Eclipse doesn't get involved in RTOSes, not necessarily, but lately I see a push on that. Any thoughts on RTOS or things like a data layer or even in the IoT gateway stack? Are you guys working? Is real-time, near-deterministic performance important to you, and what would you do about it?
So right now, as far as what I'm involved with, we don't typically get involved with real-time applications because there's a lot involved with that. You do need an RTOS, you do need deterministic data. So we can do high accuracy implementations. So like millisecond level, reading and reacting. RTOS stuff we haven't really gotten into. Benjamin, I don't know if we have projects right now.
We do not. I guess the sort of the embedded stack
right.
but I see Angelo waving his hands over there. I was getting there. For on the embedded side, you have certainly lots of other open source projects out there. That being said, Angelo over there is going to speak later today. We certainly have protocols like DDS, for example, that can help make and implement communication scenarios where time constraints are important. And I think you will have more in your presentation, right? Right after the break, I think.
But I think what is nice though is that I think as we grow as a group, these are more building blocks that we could put on top. So maybe the KoRa layer is running on top of this real-time layer. So I think that it absolutely can come, and it's a good idea.
Hi, how does this compare to something like an EdgeX Foundry, for instance?
Compared to?
EdgeX Foundry?
So I am not an expert on EdgeX. I think it's certainly a similar offering. I think EdgeX is based on microservices deployed as Docker stuff. So I think I would question the performance profile of EdgeX, how big of a system do you actually need to run it? So the nice thing about KoRa is it ran originally, our original target was a Raspberry Pi, what was the first one, the A? What it was, but it was like 128 megs of RAM, small ARM processor. I doubt that EdgeX would be able to do that. But that's mostly opinion. I have not tried this.
I think, KoRa is something that's been open source for 4 years, 4+ years now, and it's been successfully deployed in many environments. So there's lots of already a strong ecosystem around it.
And KoRa was based on, so ESF was a product before it was KoRa. So when we open sourced KoRa, ESF had been a product for, I believe, 7 or 8 years in the field already. So when we released it was already a very mature product, and it's just grown since then.
One last question.
Thank you. So I was curious, in this whole chain link, you have devices, networking, and the cloud. I know you mentioned about the security layer, So what's that, security you are proposing here, or what is available in the whole chain there?
Well, so the security, we could do a whole presentation on security, absolutely. But I think the important parts are the penetration side of it. So, keeping people out. So, for example, at least, in our corporate world, what we do is we harden the gateway itself so that physical access is restricted. And then you harden the operating system. Then you harden the Java layers. You turn off things you don't need because Java can be notoriously easy to get into, right? So you shut all that down as much as you possibly can. And then securing the channel, so it's, we're using MQTT, so it's on top of TCP/IP, so we can use all the standard SSL certificate authentication. And then there's the data security piece. So, there's a lot of pieces involved, but I think what's nice about all these open source projects is all of the service level API layers, things that you need to implement a strong security model are there. And I know they're there because we use them for our products. I'm sorry?
How do you secure the credentials?
Yeah, exactly. So so we're starting to get more into our corporate portfolio than the open source stuff. So what we do is for things like passwords, we randomly generate passwords as part of a provisioning step, right? So they're created one time, they're passed over a secure channel. with a unique signing mechanism that gets put onto the gateway. So nobody actually ever knows what the passwords are, for example. And kind of a similar story for certificates are randomly generated like one time whenever possible. I mean, there's some certificates where you can't do that, but for anytime we can do things randomly and one time only, that's what we do.
All right, thank you, Dave. So thank you, as the slide says. And I guess one call to action for you all. Dave, you mentioned the Raspberry Pi A in the good old days. Yeah. For anyone interested in KoRa and Kapua, they should just go on the website and try it out by themselves, right? Just download it. And there's lots of inspiration, I think, in terms of use cases that you've seen here. But if you have different use cases, you should totally check it out. Thank you, Dave.